Selamat petang kepada semua, terutamanya kepada para pensyarah yang hadir pada petang inilah. Saya dan Dr. Eng selaku fasilitator dalam bengkel ini mengucapkan terima kasihlah kerana dapat meluangkan masa untuk bersama kita dalam perkongsian projek NeSLA ni. NeSLA ni ialah Network Simulations Linear Algebra. Jadi ahli kumpulannya ialah saya, Dr. Eng, Encik Shibin, Dr. Saimin dan Dr. Salina. Saya mula dengan slide yang kedua. Ini ahli kumpulan kita. Jadi seperti yang this is a system of linear equations. So as we all know, ini di PISMP pun kita sudah belajar tentang algebra lah. Di mana penyelesaian dalam sistem linear algebra ni dia ada 3, unique, infinite. Unique and infinite tu biasanya ialah sistem yang konsisten. Bila kita kata sistem dia konsisten, maksudnya dia ada penyelesaian sama ada unik ataupun banyak penyelesaian. So kalau dia inconsistent means no solution. Alright, dalam tugasan kursus linear algebra ni yang kita akan pelajari lah dalam semester yang akan datang, semester 3. Dalam kursus yang baharu pun kita ada masukkanlah aplikasi network analysis. Antaranya ialah aplikasi linear algebra. Yang pertama ialah ini, network analysis. So network analysis is more about traffic flow lah. Our focus is on the flow of the traffic flow. There are many other applications such as the flow of the gas pipeline, electrical circuit, and so on. So this is one of the focus, which is the network analysis. So as you can see from the situation, we are given roundabout. So the roundabout, you can see the vehicle enter from the top. From the top is 30, and then move out. On the left hand side is 35, and then on the right hand side is 55. So this is the situation. So from here we need to do the further analysis. So we need to find out what is the optimum numbers to have to the vehicles to come in at certain point. The point is what we call knot. You can see a knot here. So this is something related to graphical theory, theory graphic. So as you can see from here, we have a knot, and then we have a rod. So the rod is biasanya ialah side lah, or tepi dalam bahasa. So we need to find out what is the optimum flow on a certain point for the vehicle to come in and move out, so that there will not cause any congestion. So this is the situation. So previously, when before PKP, so this is the situation. So you can see sometimes the student standing by the road, or you can see this is a roundabout, a big roundabout near Toran. So they have to find the locations whereby there is many vehicles move in and move out, moving lah. So they have to sit at the site for 1 or 2 hours to collect the data. So after they have collected the data, they have go back to the campus and then do the analysis and then do category all this thing and then draw the map. So this is the process. So make sure, let's say the data they collected or something wrong. So they have to go back to the place and collect the data again. But you know, in 2019, when we started our PKP, they are very strict SOP, where we cannot simply move around. Even we cannot move out from the house. So we only can complete our project. So this is a project in the Maklumat Kursus in the house, so without going out. So we have to think of an alternative solution. So this is our solution. We call it NeSLA. So NeSLA is a combination of all these application. We start with the OpenStreetMap. Definitely from the OpenStreetMap, you have to install the Java. So Java and then Python, we have to do the programming. And then after you have do the programming, calculation, and so on, then you can bring the map into the Sumo. Sumo is a simulations of mobile urban mobility. Simulations of urban mobility. So in the Sumo, you can see the vehicle moving around at a certain junction, roundabout, or certain the place lah, which you capture from the OpenStreetMap. So it's very easier for the student to have the data just sitting at the home during the PKP. So they can easily complete the assignment. At the same time, they also learn some new technology. So this is the main purpose of our project. Okay, so if you have any questions, you can ask at any time. If you don't understand any things, you can just raise up your hand and ask. So these are the program and software you need to install. The first one, Java for OSM, and then definitely the simulations of urban mobility and Python. So all this later we have to use the CMD to run the command. So make sure you have installed all this software in your computer before we start lah. If you don't have the time to download or install, you have the problem now, it's okay because I have the recording. So maybe later you can review the recording and then you can do the installation and follow the step. Okay. So this is basically, this is the concept. So as you can see, the first part is technology. And after they have the map, after they run the simulation and then they have all the data, and then they run the Gauss-Jordan. This one is, the second part is the mathematical model. So you can see from here is the Gauss-Jordan. From the Gauss-Jordan, they will solve the problem to look for a optimum value for the site lah, or for the roundabout, or for the any junction that's selected. So and then come up with the penyelesaian. So maybe you can see one or two example. So this is the example from the map, from the OpenStreetMap. Okay, then mencari lokasi dalam peta. So if you have already installed the OpenStreetMap, you can see this map lah. Okay, and then you have to export the map into the OSM file. So this one I select torrent. Okay, torrent. Okay, after you export, it will become the format in the OSM format. Okay, then and then after we do the programming, we run the simulation from the Sumo. Then we can see all the vehicle flow lah. From here we can see how many car enter one junction, one point, one knot, and then how many car. This one we can zoom in and zoom out. So we can zoom in and then we can see how many vehicles enter a certain point. All right. Then this is the assignment from a screen capture, the assignment from one of the student. So this is during PKP lah. As you can see, not many vehicles is moving around, but to me it's okay. Maybe she take a little bit long time to collect the data, is okay. So after that, you have captured the map. After that, you have to draw lah. You have to draw the map, and then this is the node, and then this is the floor, and then this is the variable from x1 to until x8. So then you do the calculation. So this is the calculation. So usually there will be as you can see the last row, so we know from this is the system. This system is how to say, wait, this system is considered as consistent. So you can see from the last row, all the digit is zero. So which mean the this two is 0, 0. So which mean this system has many solution, banyak penyelesaian. So from here, we can do the calculation from what we have learned. Okay. Any questions before we proceed?
No.
5. Okay. Wait, one moment. Okay. So now I run the open the OpenStreetMap. Wait, OpenStreetMap. OpenStreetMap. Okay, so this is the OpenStreetMap. So this OpenStreetMap, they have a conference, international conference from the 19th to 21st. I see there's many new technology we can learn. And then the online ticket is only 10, I think it's a 10 euro. 10 euro. Okay. So you have to log in. You have to log in. Usually I log in with my Google account. I log in with my Google account, my e-pembelajaran account. So you also can log in. There's no issue, don't worry. OpenStreetMap. Okay, I used to capture the map from my place because I know the place better. So you can look for the place you know better. Because you must find a place there is a heavy traffic flow. Then only you can do the calculation. So okay, so this is the place. This is the area. The student can collect the data lah. Mm, okay, actually there is two roundabout here. So actually this is a big issue for this place lah. Um, and then I always told the student, because from the previous experience, this place always have accident. So, and then we do the calculation, also show no solution. So there's something wrong with this place lah, but never mind. I just capture this map. So to capture, have you opened the map? Have you able to open the map? So I just show you, okay. So you just go to export. Okay, after you click export, can you see the manually select a different area? So because I just want to focus on this area, so I can minimize my selection. the area which I want to do calculation. All right, or you can increase on this side so that we can see more traffic flow in and out. Okay, so from here you can see I try to download the OSM maps. So I will put it in the Sumo folder. So this is the today and it's this file. Okay, save. So I've saved the file, and then I have to run the CMD. The file is still saving. Wait, So I have to run the CMD. Any questions so far? So I have to run the command prompt. So this is the command prompt. All right. So I save in the pen drive just now. So the pen drive is I. Okay. And sumo. And then go to the drive with the date. So the file is here. And I need to run the command. So the first command is to do net convert. Because I need to produce a file to do the simulation later, I need to run this command. So I can paste the command here. So net convert OSM file. Because I saved the file in torrent OSM, so I use a file name torrent OSM output torrent.net.xml. Okay, enter. So if you run, actually the map already have data. So with success. After this part, then we have to do another one, random trips. Okay. So we have the show you. So as you can see from here, we already have the torrent.net XML. So you can check your folder. You can check from your folder. The file should be here, torrent.net XML. Okay. So I already produced a file name called torrent.net.xml. Okay, then I need to run a second coding for the trips to run. Show you the command prompt again. If you cannot run the command prompt, which means you haven't installed the Python, you have to install the Python. So same thing goes here, random trips from torrent.net.xml to produce a file called torrent trips xml trips. Right?
Dr. Ko,
Yes.
meaning that we are using this to capture the data. Am I right? The traffic flow at that roundabout. Am I right?
Yes.
Okay.
Okay, then we already produced the file. Wait, I can open. Wait, Let me show you the, okay, where's the folder? I want to show you the folder. Okay, mailman, computer don't want me to share the folder. Okay, so the last one is the root, the root. So from here, I have to do another command. Okay, you can try this. Sometimes there's a problem with the coding. So we will combine torrent.net XML, torrent trip XML into torrent root.xml. Quitting on error. So cannot produce. Okay, so we have success. We have success, We have success. Okay, then you need to have this file. You need to have this file. Let me show you. You need to save this file into config. Sound like very difficult, very technical for you, kan? But I hope you can follow lah. Okay, then we need to have this config file. Okay, so just type at the notepad and then save as a config file, CFG, torrent.sumo.cfg. Okay, torrent.sumo.cfg as a file name. So with this command, I paste the command for you. But if your file, if you are not using the torrent as a torrent.osm as a sample, so you have to change the file name. Here I'm using torrent.net.xml and torrent.route.xml to combine and become a sumo file. Okay, done. Then we run from the sumo GUI. Okay, so I stop sharing. So later you have to run the sumo. So this is sumo. So this is the file I captured just now. I open again. I show you. Let me show you again. Wait. The GM is running. Okay. So this is the what we call Sumo. I go to Sumo. Open the Sumo Sumo application. So when I share again. Okay. So at the beginning, it is something you will see something like this. Okay, from the file, open network. Oh, sorry, open simulation. So this is the simulation. Okay, then you can see the map we captured just now. So we zoom in. We reduce the time to 500. If it is too fast, we cannot see the traffic flow. So you can start. You can see there is a traffic. Now this is after PKP, you can see more vehicle is moving. So during the PKP time, there's less vehicle moving lah. So the student need more time to do the calculation. See, quite congested then. Especially this area you can see. It's very congested. So these are the places we can take it as our project and do the calculation. So we can find out the problem and then we can suggest the optimum value. Maybe actually to go in depth, this Sumo simulation can draw like can increase like traffic light, okay, second alternative path and so on. So this is another calculation. So our focus for today is just to capture the simulation. You can see it's very congested, this place. So the map already have data. We just capture and then the student no need to go to the site and collect it. Okay, everyone. Boleh?
Dr. Kok.
Yeah.
That means the student no need to calculate manually, right? That means they will capture all the vehicles in and out lah for each junction. Okay.
Yes. Previously, before the PKP under the linear algebra, so the student have to go to the site to collect the data. Like we can always see the IPTA punya student pun sometimes like this they are sitting by the traffic light or they are doing some calculation, see how many vehicles pass through the traffic light and so on. But actually we can have an alternative to just use this simulation.
Because you know why? In the assignment, they don't have the collection of the data. You see, normally we give the student the data, so from there they will do the calculation. But this, the student have to go to the field to calculate the data, right? Do they have enough time to do that?
From our previous experience, the student have no problem. But definitely, because we only let's say this is a group work last time. So usually we just say you only need to go to the place to collect the data for maybe 1 hour. So during 1 hour, they have three classmates in one group, so they just standing at a certain point. But one thing we are quite worried is their safety actually. If they go to the site but if they don't go to the site, they just use this OpenStreetMap and do the simulation. I think it's better, far more better than far more better than they go to the.
But it's quite technical because you see, just now you have to use a prompt to key in all the command. So that is too technical for the student, I mean. For us also
But
as lecturer, not only for students.
but luckily during that PKP, I am Dr. Ng Li Fong, my colleague, we really face a big challenge lah, because we don't know how to solve, because SOP, you know the SOP kan, hari ini beza besok dia SOP baru bah. So that time the student cannot go out from the move out even one step from the house bah. So there are no way for them to collect the data. So we have to think of the alternative lah. So, okay, you can try. You can try, and then I can help you from time to time, because now it's only 2:46. It's actually it's very simple. You can see I just do it because I already used to it lah, maybe. Is there any questions from the student? I think the student will go through this in the linear algebra very, I think in the third semester. Oh, wait, we have another attendance. So this one is for the SPL-KPM. So because the SPL-KPM is offline now, so all the lecturers can fill up lah. The student also can fill up, no problem.